Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 53. Today we will be covering the area of circles. We've done areas of straight-sided shapes. It's time to do the curved-sided shape. Our first investigation is going to show us how a circle can be like a rectangle when we measure the area. So use your compass to make a large circle, then cut out the circular region. Fold your circle in half and then in half again. Try to fold it 4 times so that you have a total of 16 wedges when you unfold it. So you have your circle, you have folded it in half and then in half again, and then one more time, and then one last time, and then you should have 16 wedges, so you're cutting out the wedges that look like this. Arrange those wedges in a row, alternating the tips up and down to form shapes that resemble a parallelogram. So you have a wedge shape here, and then you're going to have a wedge one down here. So you're alternating up and down for those wedges, and you're going to put them all together. There are some bumps in your shape. If we continue to cut the wedges into smaller and smaller pieces, we would make a shape with smaller and smaller bumps. Cutting an infinite number of wedges would give us a rectangle with smooth sides. What would the length of the base be? What would its height be in terms of the circumference? The radius of the original circle is r. The circumference is 2 pi r. So give the base and the height of the rectangle in terms of r, then find its area in terms of r. So let's see what that looks like. You have a circle. You can cut it into 4 parts. You can keep going, cut it into 16 wedges. So you've gotten your circle, you folded it enough times that you have 16 parts. You cut out those parts and arrange them right side up, upside down, right side up, upside down. And it looks a little bit like this. This one is more of a parallelogram because we didn't cut our wedges super duper small. If you were to keep going and cutting them infinitely small, this would turn more into a rectangle. But we can still find the area of a parallelogram just the same, or very close. So this side of the rectangle or parallelogram would be r. Because we cut out our wedges, remember they look like this. So they went from the center to the outside. That was one side of the wedge, so that would be the radius. And then what would this length be down here? Well, we have half of the wedges outside on this bottom and half of the wedges on the outside on this bottom. So if the entire circumference was 2 pi r, we have half of it on the bottom and half on the top. So we have half of 2 pi r, which means we have pi r down here on the bottom. So assuming this is more of a rectangle, we have the one side as an r and the other side as pi r. So the area of this would be r times pi times r. Well, 2 r's multiplied together would be r squared, so we'd have pi r squared. So our circle area conjecture, the area of a circle is given by the formula A equals pi r squared, where A is the area and r is the radius. Remember, we don't have to define pi because pi is a number. It is 3.14159, and then it keeps going. Let's look at some examples using the area of a circle. A small pizza has a 10-inch diameter, while a medium pizza has a 14-inch diameter. So remember, diameter is all the way across. This one is 10. This big one is 14. How much bigger is the area of the medium pizza versus the area of the small one? So first we have to find the area of the small pizza. It's pi r squared. If our diameter is 10, then our r is 5. 5 squared is 25 times pi. For now, I'm going to leave it in terms of pi. How about our medium pizza? Again, it's pi r squared. And if our diameter is 14, half of that is 7 for our radius. 7 squared is 49 times pi. So the difference in area is 49 pi minus 25 pi. That is 24 pi. And I'm sorry, we missed units up here. This would be inches squared and inches squared, since our radius is in inches. So the difference is 24 pi inches squared. And if you want to do 24 times 3.14, you get about 75 inches squared. That the medium pizza is bigger than the small. Our second example, the area of the blueberry pie is 256 pi centimeters squared. So again, I'm going to write down area is 256 pi centimeters squared. What is the circumference? So here we have the area. Let's use our area formula. Area is pi r squared. So if pi r squared is equal to 256 pi, we can start by dividing by pi. Pi is just a number, so it's like we're dividing by 3.14. Now I have that r squared is 256. Well, to get r by itself, I'm going to take the square root of both sides. R is equal to 16. Now how do we find the circumference? Their circumference is 2 pi r. So 2 pi times 16. That means our circumference is 2 times 16, which is 32 pi. And our units, r would have been 16 centimeters. So all we would have had is the centimeters here. So 32 pi centimeters is the circumference of that blueberry pie.